Hi, my name is Al Archambault. I'm the product manager for VFD products at Mirus International. I'd like to welcome you here today to our facility where we'll be testing a 100 horsepower variable speed drive on one of our Lineators. Today I'll be running and loading this VFD up to full load, 100 horsepower on a squirrel cage induction motor. This is the motor generator room, and this is the 100 horsepower motor that is connected to the VFD that you saw in the H&E lab. The VFD motor is mechanically connected via its drive shaft to an identical squirrel cage induction motor here. The VFD is started up and set to run at 60 Hz. Once the motor is up to speed, we will take the other motor and switch it to the line using this start button here. If we now increase the speed of the VFD motor to about 63 Hz, we will also increase the speed of the driven motor, which will become a line-excited induction generator and provide a load for the VFD and motor. This setup allows us to test the VFD and our Lineators at full load. The VFD is powered up and ready to receive a run command from this button. The sound you hear in the background is the VFD accelerating the motor. The VFD speed is set at 60 Hz, which is full speed. The driven motor, the induction generator, is switched across the line. The funny sound you just heard was the driven motor syncing with the 600 volt 60 Hz supply line. Now the driven motor is an induction generator. The VFD frequency is increased, setting the load to 100%. The bottom trace on the Fluke scope shows the VFD input current waveform. The top trace in red on the Fluke scope shows the VFD DC bus ripple voltage. Using the Fluke scope meter software, we will download the recorded waveform onto a computer so that we can look at the harmonic spectrum. As you can see, the VFD input current waveform has a total harmonic distortion of about 31%. All of the testing we've done so far was done on the VFD without the Lineator connected. We're now going to shut down the drive and connect the Lineator and do the test again. We now have the VFD running at full load with the Lineator connected. Again, the bottom trace on the Fluke scope shows the input current to the Lineator and VFD. As you can see, the current waveform has changed dramatically. The top trace in red on the Fluke scope, which shows the VFD DC bus ripple voltage, has also changed dramatically. As you can see, the DC bus ripple voltage has reduced quite a bit. This will reduce the load on the DC bus caps in the VFD. Once again, using the Fluke scope software, we will download the recorded current waveform onto the computer where we'll be able to analyze the harmonic current spectrum. As you can see, the total harmonic current distortion of the VFD with the Lineator connected has reduced dramatically. Thank you very much for taking the time to watch this video, and I'd like to remind you that you can call us anytime and come and visit the Harmonics and Energy Lab.